paradox of heat death, or thermodynamic paradox, challenges the notion of an infinitely old universe using thermodynamics. This concept was first introduced in 1862 by Lord Kelvin and further developed by Hermann von Helmholtz and William John McCorn Rankine. The paradox questions how an eternal universe has not yet reached thermodynamic equilibrium. Underlying the paradox is a traditional viewpoint that the universe has always existed as we recognize it today, unchanged and with matter that is ever-enduring. The paradox of heat death sprung from this worldview and suggests the need for a paradigm shift to reconcile the contradiction. At the core of this paradox was the second law of thermodynamics, as proposed by Rudolf Clausius and Lord Kelvin. This law states that heat can only flow from a warmer object to a colder one. If the universe had always existed, it should now be cold and isotropic, characterized by a uniform temperature and matter distribution. Kelvin illustrated this by comparing the universe to a clock gradually slowing down and continually dissipating energy. The presence of usable energy indicates the universe has not yet stopped. This is contrary to Kelvin's model, which did not factor in the conversion of heat into mechanical energy, which he describes as a rejuvenating universe scenario. According to thermodynamics, a hot object will warm its cooler environment until a uniform temperature is achieved. If the universe were infinitely old, then there should be sufficient time for stars to cool and heat their surroundings. The entire universe should then either contain no stars or everything should be as hot as stars. As a result, the universe should gradually reach a thermodynamic equilibrium, a state in which no further work is possible due to the lack of free energy. This is essentially the heat death of the universe as predicted by Lord Kelvin. To counter-argue this paradox, Lord Kelvin pointed towards the sun and stars as evidence that the universe has not reached thermodynamic equilibrium. This is evident by the fact that work and entropy production is still possible, and that there are objects at different temperatures. Helmholtz and Rankine further fleshed out Kelvin's theory. The presence of celestial bodies at varying temperatures further emphasizes that the universe is not in thermodynamic equilibrium, undermining the belief that the universe is infinitely old. Modern cosmology, with its belief in a Big Bang approximately 138 billion years ago, circumvents this paradox, as this time frame is not sufficient for the universe to have reached thermodynamic equilibrium.